Hello, and welcome to Emerging Construction Management Technologies. And the panel you're going to be hearing today will consist of all members of the National Academy of Construction, but a word on that in a second. I'm Bob Priety, a member of the National Academy of Construction, and also a fellow of the Construction Management Association of America. I'm not going to bother reading my bio to you. Needless to say, I've been around the industry too long. What we're going to be covering in the session today is focusing on some select emerging construction management technologies. These will include 4D construction digital twins, AI in construction management decision support, finding objects in a scene using AI, and then some emerging issues in AI that the construction manager needs to be sensitive to. We hope that as we go through this, we'll also create an awareness of other relevant resources that are available to you from the National Academy of Construction. And those will include executive insights, a collection of safety white papers, and a series of Ask Me Anything videos, which I highly recommend to you. So our panel today consists of Greg Bentley, a member of the National Academy of Construction from Bentley Systems, Amina Fayek, also a National Academy of Construction member from the University of Alberta, Carl Haas from the University of Waterloo, and also a member of the National Academy of Construction, and then myself, Bob Priety from Strategic Program Management, my little consulting company. So first, we're going to talk about a range of emerging construction management technologies. We'll cover only some of these technologies because the rate at which technology is changing is very fast. So as we said, we'll talk about digital twins and CM decision support, safety management, a little bit on project health diagnostics, and supply chain management. So our first speaker is going to be Greg Bentley. Greg is CEO of Bentley Systems. He's a fellow of the Institute of Civil Engineers and a member of the National Academy of Construction. So with that short introduction, we're going to have Greg talk to us about 4D construction digital twins. Greg, let me turn it over to you.
Bob, thank you. And while I'm a proud member of NAC, I don't happen to be a construction manager. Bentley Systems is a world leader in infrastructure engineering software, and that includes for project delivery, however. And while infrastructure projects are in our 3D reality, it seems to me that construction management is about the 4D aspect, the occupancy of space and time. And I want to highlight this new technology of 4D construction digital twins in the way that you may most relate to by showing it on a project. Because we otherwise hear so much about construction being behind in going digital, I chose a project which, while it's more international than national, I think we can characterize as a celebrated triumph for the construction management profession, and where the credit was given to digital twin software and thinking. After the bridge collapsed in Genoa in August 2018, the challenges for project delivery, as you see here, included a swoopy design by globally renowned architect Renzo Piano. Do you love being accountable for cost and schedule on projects like that? But how often does construction management make front page news in the Wall Street Journal for a great outcome? And though we can't take any credit for the rainbow in the after photo here last summer, the outcome turned out to everyone's satisfaction. Engineering construction as a source of national pride, ahead of schedule, and this was in Italy. The project delivery organization had presented their approach at Bentley Systems Year in Infrastructure Conference late in 2019 and gave credit to the digital twin approach and our software playbook, which you see here. An infrastructure digital twin combines the digital context with digital components across a digital chronology. And for how these come together, I will use Atal Fair's slides and videos with their permissions. The digital context is an engineering-ready reality mesh model of the site and the environs created by our context capture software from drone flights and overlapping digital photos. This will be continuously surveyed and updated throughout the project. The digital components for the design were created by generative scripts and fabricated offsite in parallel to industrialize a shorter duration for the project. Our Synchro software creates the actual 4D construction model with the time slider across the top. Instead of dumbing down the 3D model to 2D, the work breakdown structure is constructioneered in 4D. It can still be used in P6. For an industrialized project with modules and interfaces for shortest duration, this is even more essential in minimizing the construction management risks. Italfair uses the term 5D to describe the intrinsic quantification of costs and materials represented in the digital components. The digital twin enables analytics to track the progress of costs as well as schedule trends across the performance of the project. Italfair uses the term 60 to describe their pride in the sustainability achieved in the project as well. And where 70 refers to the digital twin's usefulness during the operating life cycle of this bridge. Here's an example where I guess they hypothesized ahead a few years. We hope this isn't the actual pier on the bridge, but where you can, from handheld cameras, create the context, the reality model, and one can imagine Carl's going to talk about machine learning being applied to recognize problems of this sort during maintenance. And this goes beyond now, where in 2019 they were. It's possible to use mixed reality, which we're also going to hear about from the others today. On a site, this is with the HoloLens, so that the 4D construction digital twin is literally integrated into the on-site construction management process. Bob, back to you.
So our next speaker is going to be Amina Robinson-Fayek. Amina is a professor of civil engineering at the University of Alberta. She's very active in the construction engineering area and a leading researcher on artificial intelligence. Amina also is a member of the National Academy of Construction, and Amina is going to talk about the use of AI in CM decision support.
Thank you, Bob, and thank you for the opportunity to present today. So often in construction, there's a heavy reliance on experts to make quick decisions based on subjective information and experience rather than on precise numerical data. Artificial intelligence consists of a family of techniques, one of which is called fuzzy logic. Fuzzy logic is a very precise mathematical technique that allows us to translate natural language and expert knowledge into a form that computers can understand. This picture explains the concept. On the left side, you see a strict engineering approach to the problem, which is accurate but may not lead to the intended results in time. On the right side, you see a fuzzy logic approach, which solves this problem in a faster way and prevents a potentially devastating accident. Human beings make very good and often better decisions on a daily basis using subjective and imprecise information. If we ignore such reasoning or force information to be modeled using methods intended for other purposes, we develop systems that are inaccurate because they only capture part of the problem. So while fuzzy logic is great at modeling human reasoning and subjective information, it cannot learn from data or adapt to new contexts, which is very important in construction, since no two projects are ever alike. Machine learning is another AI technique that uses data to solve problems that are not easily solved statistically or using conventional algorithms. Machine learning models improve automatically through experience in the form of training with new data. However, machine learning requires large data sets in order to be accurate, and the resultant models are often black boxes with logic that is not transparent to the user. So by combining fuzzy logic with machine learning, we can create better models that capture both expert knowledge and project data and are capable of making their reasoning known to the user. By integrating these AI techniques with optimization and simulation, we can very realistically model construction processes that change over time so that we can accurately predict and improve construction performance. For example, construction productivity is affected by many factors and practices, some of which are difficult to quantify and are best evaluated subjectively, while others are quantitative in nature. Another important aspect of labor productivity is crew motivation and performance, which is largely influenced by human and behavioral factors such as crew skill, teamwork, trust, and foreman's leadership style. By combining fuzzy logic, machine learning, and simulation modeling, we're able to model the interactions between crew members and crews on a project to determine motivation levels. We're also able to create models to determine the most important factors that affect productivity while accounting for the human element so we could better predict and ultimately improve productivity. Another example of our AI applications is in the area of risk analysis. One of our industry partners, Capital Power, is a large owner organization that constructs power generation facilities. Risk management and assessing contingency reserve are critical to their operations. They were using Monte Carlo simulation for risk analysis, but facing a number of challenges in applying it. Like many construction organizations, they were relying on subject matter experts to choose probabilistic distributions based on experience rather than historical data, which was time consuming, and they weren't explicitly accounting for opportunities. We used our AI methods to develop a software tool that allows their experts to express the probability and impact of both risks and opportunities using linguistic terms such as high, medium, and low, and to calibrate each expert's meaning of these terms to suit different projects. We also enabled them to weight each expert based on his or her level of expertise rather than forcing them to reach consensus. Our tool has saved them significant time in conducting risk analysis and has helped narrow the uncertainty range to free up contingency reserve for use on other projects. As a result, they've replaced their commercial risk assessment software with ours, and our other industry partners want to use this tool. So we've generalized and enhanced it so it can be user customized to suit different project types and construction sectors. A lot of our work relies on collecting subjective and behavioral data, which we've traditionally done through interviews, surveys, field observations, and discussions. Biosensors and physiological sensors combined with AI techniques allow us to directly measure human emotions, cognitive skills, fatigue, and reactions to the environment to support our research related to productivity and safety. Wearable sensors and wristbands, chest straps, headsets, safety glasses, and mobile phones make this technology more feasible on construction sites. In addition, we're exploring the use of exoskeletons combined with virtual reality and AI techniques to support workers in performing tasks in order to improve productivity, reduce fatigue and injuries, and improve safety. One of the biggest challenges in applying AI techniques in construction is adapting them to suit the construction domain. Despite the power of AI, each individual technique has its limitations. The most powerful methods combine one or more techniques in order to capitalize on their individual strengths while at the same time overcoming their limitations. The potential opportunities are significant when we consider how we can capitalize on both the richness of data and the valuable knowledge and expertise of construction practitioners. We also need to search for solutions at the intersections of disciplines in order to really advance AI research in construction. We are in the age of big data and powerful computing. An emerging area in construction is the use of automated methods for real-time data collection and streaming, including imaging, geospatial technologies, sensing, and augmented reality.
Our next speaker is Carl Haas. Carl is a member of the Canadian Academy of Engineering, a fellow of ASCE, and a research chair up at the University of Waterloo. Carl, like the rest of our panelists today, is a member of the National Academy of Construction. Carl is going to talk a bit about how AI further enables building information models. Carl, over to you.
Thanks, Bob. Hello, everybody. So I'm drilling down here to a pretty narrow topic. So what does the challenge of finding objects in construction scenes got to do with improving project management performance? Quite a bit, I think. I think it can help us to reduce rework, provide progress feedback for management control loops, support quality control, improve safety, improve trust and transparency, and more. So today we can get scenes of construction sites and fab shops, such as the image on the right, in numerous ways. The cute little fellow on the left is a ClearPath robotics platform outfitted with Velodyne LiDAR units, a Ladybug 360-degree camera, GPS, and inertial motion units. It can get us 3D scans and digital images of everything in its path. To its right are more common approaches, such as a tripod-mounted laser scanner for getting 3D images and point clouds of scenes, and a handheld laser scanner. You can put these types of scene acquisition tools on a drone as well. In this scene from about 15 years ago, we knew where our laser scanners were and where the building being constructed was, so we knew where to look for objects in the scene like columns, beams, and floors. And we could compare what we found with the resource-loaded 4D building information model of what we were constructing. The result was that we could track progress and earn value with about 98% accuracy on a daily basis, pretty high frequency. It worked well for reinforced concrete reinforced concrete and structural steel construction. It worked less well for mechanical, electrical, and plumbing work. That was because objects were often not quite where we expected them because of undocumented changes and normal field routing. People have solved this problem since then by figuring out how to convert scans to building information models and how to use other tricks. Now there's commercial options to help you do this. So what if we could find specific objects in a scene where we only had a general idea of where to look for them? People have also figured out how to do this using techniques from the autonomous navigation world, like fully convolutional neural networks, which is a sort of a deep learning approach. In many ways, this will help us improve safety, avoid rework, and support QC as it serves emerging commercial apps for these purposes. It will also help us develop digital twins for management of legacy facilities and to create tie-ins for maintenance work. Here's an example of using deep learning to find and read tags on equipment, and then actually to find the equipment itself in the point clouds. We use this approach and some of the previous tools to help a nuclear power plant operator, Ontario Power Generation, develop digital twins of its existing plants. All this is getting to the point where you can share the designed objects and scans of the fabricated objects through web interfaces and cloud-based services. This means that, for example, you can remotely check using a heat map between the designed object and a scan of the fabricated object that it is built right before you allow it to be shipped to your site, and you don't have to travel to the fab shop to make sure. In the future, you'll be able to do cool things like check whether a magnetic rod array is going to fit within spec before you assemble it. And this is another application, for example, of HoloLens. It's a mixed reality approach that needs to find an anchor to objects in the real world to work properly. And also in the future, you'll be planning with real objects in the virtual world before you do the work. And this will help you improve safety, for example, when you're decommissioning nuclear power plants. You'll also be able to guide your actions in mixed reality views to help reduce rework, like this example of masons and masonry training. We're just at the tip of the iceberg right now, and I'm looking forward to the discussion to figure out where we're going.
Thanks, Carl. I'm going to focus on some emerging issues in AI, and I'll talk about some opportunity areas and then some issues that come with them. So first opportunity I want to focus on is predictive project analytics. So how do we know when a project or a construction site is coming off the rails, where it's going to result in a bad outcome? So through some work that's been done some number of years ago, there are some predictive project analytics tools that have been developed that are very good at predicting project failures or task failures as opposed to project or task successes. We seem to be better at understanding some of the common characteristics of failure than the common characteristics of success. In the particular application, we were able to detect a failing project about 2 months before the project manager was raising his hand saying, I think I have a problem. So a very, very valuable tool. Let me just spend a minute and talk about that technique in some simple terms. So those of you who have a smartphone and it has facial recognition, basically the camera looks at you and says, aha, this looks like the picture that says I'm supposed to let this person onto the phone and have access to the apps on the phone. Same thing happens when you're entering into a secure complex or in criminal settings, if you will, law enforcement settings. We're looking to identify an individual that fits someone that they might be looking for example. So what happens here is you train the artificial intelligence using a set of project data that allows it to learn what a failing project or a failing task looks like. And then when it sees those patterns or things that might look like those patterns, it can predict the future, if you will, or at least most importantly, call your attention to the fact that you may have a problem much earlier than you otherwise would have recognized. A second area, which I think is late coming into the engineering construction space, but which holds huge potential, is in supply chain management. Control towers, supply chain control towers, think of it as analogous to the aviation setting at the airport where the control tower is controlling incoming and departing flights, taxiing flights on the ground, and trying to do all of that while optimizing landings and takeoffs and ensuring a level of safety and non-conflict in the process. Supply chain management and control towers are used in the industrial space for great effect. And probably the single biggest test of those came with the onset of the pandemic, when supply chains worldwide were rapidly reconfiguring, and the control towers were able to predictively anticipate where shortages and demands would move to or move from. And increasingly, I think this has opportunity, not just in the supply chain feeding a large construction site, for example, but also in management of commodities, materials, equipment, and probably labor as well on site. I think there's a micro version of these control towers that's available to the industry. So, we could spend days talking about construction technologies. I just want to mention a couple others and then kind of shift into some issues. So first, the robots. We've seen various forms of construction robots. Carl showed you one with the little ladybug camera on it, if you will, as a construction robot. There's a great video out on YouTube of Do You Love Me? I think it's Boston Scientific's dancing robots. Highly recommended. I was going to include it in the presentation, but I didn't think we had the time for it. But one of the challenges that we'll face as we introduce construction robots onto the site is the fact that we will now be working with a mixed labor force, a robotic labor force and a human labor force. And this will introduce new safety issues, new communications issues, new interaction issues, and certainly new opportunities at the construction site. 3D printing, I think, is an area that we will see a more focused use of. I've seen some fairly substantive things printed 3D, 10-inch inside diameter, heavy walled pipe, flanges, just amazing what you could print. The quality of it was amazing, but I've also seen 30-story buildings, residential buildings, 3D printed. Not so pretty, but interesting and effective. And we're still at the beginning stages of this technology. More interesting uses may be in printing spare parts, at least temporary spare parts for critical components in construction equipment on site, for example, where it may take several days to get a full-scale permanent replacement part. Exoskeletons were mentioned by one of our previous speakers. And again, I think this is part of that intermediate world between the human labor that we manage now at a construction site, the robots of the future, and robotically or mechanically enabled exoskeletons, helping human labor do much more than what would otherwise be humanly possible. So a couple issues I just want to lay out there, and we can pick them up more in the Q&A perhaps, is data bias. Your AI is only as good and only relevant to what it was trained to do. So as an example, I mentioned the predictive project analytics. We trained on industrial projects, oil and gas projects primarily. But when we tried to apply it to infrastructure projects, the results were garbage. They were meaningless because they had not been trained for a different kind of execution model. Ethics in AI, not something you might think about, but maybe a simple example. If we train the AI to look at screening job candidates, and we screen them against our existing population, and let's assume for a second that our population are all white males. The AI is preferentially going to screen candidates that look like what it was trained for, all white males. So you have to be sensitive to those, to the ethics of the AI, especially as we get into some decisions around supply chain, labor management, and even in contracts. Remember, 2 out of 3 large projects fail. We don't want to be perpetuating failure. That's a bias issue, but it can also be an ethical issue. 2 last quick points. Validation and verification. Engineers sit, they calculate, they make deterministic calculations. Other engineers can arrive at those same deterministic values. AI is a probabilistic solution. How do you check it? How do you confirm it's fit for purpose? This is an area where I think the industry, organizations like CMAA and ASCE, still have a lot of work to do in terms of how do we validate AI is fit for purpose, if you will, that it's giving meaningful and verifiable results. And then finally, cybersecurity. I think this is something we're all gaining increased awareness of, but recognize that whether it's the AI or whether it's the BIM models that Greg outlined to you, corruption of those models through a cyber attack can result in loss of life in the extreme. So cybersecurity is going to be something that's much more significant to all of us. So what we've heard about from our speakers is 4D construction digital twins from Greg, the use of AI and CM decision support from Amina, and Carl talked about finding objects in a scene using AI. And I've tried to at least whet your appetite on some emerging opportunities and issues. You can reach us all. Our contact information is here. It's also available on the National Academy of Construction website. And with that, we'll go into some questions now. Greg, I want to start the question and answer period with a couple of questions to you. The first is I'm going to drag us out of the technology for a second and try to get us up to the 50,000 foot or 100,000 foot level. You know, we hear a lot of talk, and I have to say again, of an infrastructure stimulus. Maybe we'll see one this time, but either way, we are seeing increasing investments in infrastructure, some as a result of forward planning, some out of absolute necessity. But how can we take these digital tools, tools like BIM, tools like AI, and use them to get a better result, a better outcome in the investments that we're going to make in infrastructure?
Well, Bob, I do like to think that it's likely to come about that we'll spend more of our national treasure on infrastructure, not for stimulus, because it provides a great return on investment, that return on investment, we'd like it to last longer. And if we've learned anything in a pandemic, perhaps it is that our infrastructure assets need to be more adaptable to new fitness for purpose as things like pandemics or weather would come along. They need to be more resilient, maintain their fitness for purpose. And a digital twin, thinking of a digital twin, that while we're at it, along with the asset, let's construct a digital twin that'll pay off and increase that return on investment, enable the asset to have a longer and more useful life. By the way, the digital twins can be applied to updating and improving the infrastructure we have already. So hopefully we can have our determination back to now a national aspect of this, that, you know, we lead the world in going digital, and that's become more clear than ever in the past year. Let's combine that with our infrastructure initiatives to upskill what we do for infrastructure project delivery in the US, and then lead the world in turn for at the advantage of Americans. We've all learned by our work being completely virtualized, as in this seminar and session here now, we could be working on projects anywhere. And I take note of, for instance, and Carl referring to, you don't need to visit the fab shop, and Amina had examples of this as well. And I showed that the engineer doesn't have to, you could be working on projects anywhere. Let's bring American expertise. And maybe our National Academy of Construction is a great example of having experts whom are practitioners, whom are academics, whom are technology providers. And, you know, I don't like the term digital transformation. It suggests it'll all be over. We're going to be going digital. That's the term, by degree and eclectically and pragmatically, which is what I take away from all the speakers. When Amina talked about intersection of disciplines, intersection of techniques, we all should be progressing constantly. We should have a thirst to be applying in our projects a greater mix of what we've been talking about here today, and not wait for someone else to show how you can do it all. Let's show in the US how we can be more pragmatic and eclectic in improving the results of our investment by having a digital aspect to that, upskilling ourselves and extending the life of what we construct.
Greg, that's great. I want to pick up on a couple aspects of that, but I'd be remiss if I didn't comment. I think one of the opportunities that are presented as we go digital, continue to go digital, I think is around that resilience point, which we know is a growing challenge in infrastructure. It's also around that facilities management point that the digital twin enables. And, I have to link that back to a grand challenge goal set by the American Society of Civil Engineers on reducing life cycle cost of our infrastructure by 50%. And it's going to be tools like these digital twins that are going to help enable that. But I want to delve a little more deeply into BIM first, and then through that lens, look into AI a little deeper. So probably everyone in our audience has experienced or used 3D BIM on one of their construction projects. In your talk, Greg, you talked about 4D BIM, and I'd like you to maybe talk about 4D BIM, but from the aspect of how does that change what the construction manager is going to be needing to think about? What are the new opportunities it will create for?
Well, I think most of us realize in construction, most construction now starts with a 3D model. It just doesn't start with the 3D model that the engineers were paid to create, because often it's not delivered in procurement and so forth. It's dumbed down. And, the shame is to have the constructors start over again with their 3D model. So to go from 3D to 4D in construction, rather than going from 3D in design to 2D in construction, if we lose the design model and the optioneering that went into the engineer's thinking, then we won't have a useful digital twin that can become more adaptable and resilient when those scenarios that were contemplated in design actually occur over their life cycle. So it's really important not to dumb down from 3D to 2D, but to enhance and constructioneer, we say, from 3D to 4D. in the handover from design to construction. And that's where in design build and P3s, like in Canada, where our other panelists are from, we're making progress and understanding. But part of it is just the mindset that going from 3D to 4D is about sequencing, modularizing, fabricating, industrializing. A couple of our panelists said, well, you said catch up to industrial. We can do it more so when we have a continuously modeled from engineering through construction and then through continuous surveying, which we were talking, it's a kind of a common element among all of these strategies. If you can automate the capture of the existing conditions, the conditions that precede construction, it's better project, the construction conditions throughout construction, and then the conditions thereafter for retrofit and so forth. It's kind of a common area to have this digital chronology slider across our digital representation. So that's what we mean by 4D digital twin. It isn't only applicable to construction, but construction is really critical. If you don't get 4D in construction, you're kind of blowing the chance to have a digital twin for the life cycle.
Yeah. So Carl, how does the use of AI further enable 4D BIM, if you will?
Sure. Well, AI is the tool that allows you to use BIM to control processes and machines. So you can use AI to, for example, the feedback you get for automated earth moving. You have a 3D model and you have AI involved in getting information on what you've done with the dirt, moving it around, the condition of it in your machine. And that sort of thing that's existed commercially already now for at least a decade is becoming absolutely possible and feasible to do in a fab shop, for example. So as long as you have the model, it's a kind of a control signal or a reference, and you can control a tremendous number of automated processes. You can control feedback loops for quality control and earned value tracking. And you can visualize using things like augmented reality if you have the model and if you have the AI paired up with that. So
Yeah.
it just opens up a huge array of opportunities.
Yeah, if you have the model, then the recognition of the images from the machine learning can be that much quicker and better because you know approximately what to look for and where to look. It's
absolutely
that much more feasible. And I would add, we talk about robotics as if it's down the road. Indeed, heavy civil projects, I say the first autonomous vehicles on any road are the machine control graders and pavers that today are controlled robotically. That's the state of the art. We should stop apologizing and waiting in construction. We should get on with improving what we're already doing.
Yeah, I think there's some other, I think, significant opportunities. And then, Amina, I want to come to you next. But one of the things we know is that despite our best plans in the field, the sequence of construction often changes on us. In fact, I think that process begins on day 2 of a construction schedule, at least from my experience. So one of the advantages I think AI has is creating awareness, earlier awareness, and this is where that supply chain linkage into that, if you will, real life 4D BIM model, I think is important. But I also think it has another potential, which is one of the unintended consequences of us working around delayed materials, for example, or late arrival of equipment, is that we can create unintended consequences. We can create rework for ourselves. And I think with the advantage, an advantage that AI would provide us is making an assessment whether proceeding with contingent work has a net benefit or a net cost when one considers rework in, for example. So I mean, I want to kind of go to you though and talk about what are some of the other challenges you see in implementing AI in construction?
So thank you, Bob. And I think you touched on some of the important ones in your presentation, and I want to just speak to a couple of them. You talked about context, and you're absolutely correct in the sense that we are limited by the context in which we train some of our methods, particularly machine learning, which is largely data-driven. So there are areas of research that we're even focusing on in terms of how to adapt our models rather than create new models for different contexts. And in construction, that's so critical because you gave the example of different construction sectors, even different projects. You know, we hear our owners say, I can have two projects that look exactly like on paper, but in executing them, they're very different. And often that's because of the human element. And so I think that, in my opinion, one of the areas that we really need to address is how do we marry all these different AI techniques to capitalize on the strengths of each one and overcome, you know, every AI technique has its own limitations. So I think context adaptability is very important in construction. You talked about validation, and I think validation of models is very challenging because often when we design AI models, we're looking at variables or factors that we haven't captured historically. So in our work, when we develop these models, we're often defining new factors or making factors that were implicit now explicit. So in terms of trying to test or validate, the two options we have are to compare them to existing methods. In the example I gave, it was against a Monte Carlo simulation, and see that our methods are even better or improve upon that. But really it's testing with real world data. And I think all three of you, Greg, Carl, and Bob, you mentioned this aspect of relying on our industry to use the models and test them against real world data. The other thing is the human face validation approach, where we have experts look at them and they are able to judge if they're giving us reasonable results. The goal, though, is to get better results than previous methods, not just to replicate the results of existing methods. And then lastly, you touched on the ethical aspect. I think there's a huge science behind the ethics of these approaches. And, you know, we certainly need to make these models diverse in that they can handle multiple scenarios. So I think those are the main ones that I would be focusing on in the near future. Thank you.
Greg, before I comment on bias in data, this has got to be an issue that's of primary concern, I would think, as you develop your various tools in this space. Do you have any thoughts on data bias or data in general that you might want to add at this point?
Well, each of us have talked about the source of data that can be automatically captured through imaging, or, imaging used to require, in every case, scanners. Now it's overlapping photographs from digital cameras and so forth. It's being captured anyway. And you imagine that we all are getting used to cameras being everywhere. They'll be fixed and stationary in our infrastructure assets for the future. That data is so useful, so objective, that frontiers of research for all of us in applying that will be developed every day. So my point is the machine learned data, it's only a portion of AI, but we're nowhere near the point of diminishing returns in what we can do when we really recognize and classify tags. And so, there's so much more we can get from from what is a very little cost to capture in a construction process. And then if you have the digital twin, you relate the two and difference the two. I mean, you don't get into any controversy, I think, in data bias when you're talking about these aspects of going digital that are low-hanging fruit at the moment. Yep. And foreseeably, I think.
Yeah, I think with respect to, let's say, the physical environment, representation of that physical environment, probably less a bias issue. But I think as we get into the management aspects, the more human aspects of construction, this, I think, is the area where bias enters. I want to comment on data for a second. So in an AI development project I worked on, we did not have a shortage of data. As we looked at trying to distill the data down to what were the most meaningful pieces of data, we tested who actually was using the data that we had been collecting for decades. And I'll use some representative numbers. So if we were capturing 1,000 different data points, and we would have a timed series of values for each one of those data points. Well, out of 1,000 data points that we might have been capturing data on, what we found was 70% of them really weren't being used by anybody. So 70% of the data that we've been collecting for decades, there was no obvious consumer of it. Now, that is not to say it doesn't have value. It just did not have value within the context in which we were operating. And then out of the remaining 30%, only about 12 to 15% of that data was actively being used at a management and senior management level. And so that management and senior management level where a lot of this audience is going to be sitting. So I think one of the things that AI, I think, helped us do was to see the trees for the forest, because we didn't know which of these 1,000 trees we should be paying attention to. But it turned out that if 10 of them were changing their leaves early, it was telling us something very bad about the forest, if you will. So I think that concern about bias is a real one I have. And Carl, I wanted to maybe have you go down that path a little bit more around the notion of data bias, if you will, because one of the jobs of the construction manager is going to be making a judgment that the AI tools that he's being given are fit for purpose. You know, not that the AI construction management diagnostic tool was developed using oil and gas projects, but he's building a highway. And, you know, is it garbage in, garbage out, or what? So maybe you can speak a little bit, and then Amina, maybe you can add a little bit to that as well.
Yeah, I think I'll try to address two aspects of that. One is more around deep learning, and the other is around machine vision. So the deep learning part is where we have those huge databases that you were describing, or they could be databases of images of people's faces, and we train some kind of deep learning algorithm to recognize things, recognize situations on a project that are leading to collapse, or recognize particular faces. The challenge is all of that deep learning is past looking. And when we have paradigm shifts or we have phase shifts in our situation, it can be very dangerous to rely on those. On the other hand, if we understand a tiny bit about how they were developed, it turns out that there's some really good algorithms or approaches that Amina was talking about where we can take past algorithms and adapt them pretty quickly. So when we did that tag reading, we started with some tools that were used for recognizing license plates in cars. And we could start there and we could retrain to look for types of tags in a plant, and it worked very well. So we just had to know that we could adapt those tools. So moving to the machine vision, actually there we have almost the opposite of bias. We can scan a project with a high resolution laser scanner, for example, now, and we can use that information to automatically update the BIM. So we can use that. That is going to be, that's in a sense reality capture for operations and for digital twinning later. So where we might start with an ideal BIM, when we do the construction, we have issues, we have changes, we have deflections. We can update that BIM now with that information and create absolutely precise and rich data to feed a digital twin. So there, it goes both ways, actually, I think.
Amina, is there anything you want to add there?
Yeah, so thank you, Bob. And Carl, those are great comments. And I'm going to speak more about the human element that, Bob, you mentioned. So when it comes to construction practitioners who have a lot of experience, they need to see that these models reflect their common sense experience. So in addition to the machine learning piece, which is very important because there's so much knowledge in the data that we may or may not know explicitly, we focus a lot on capturing expert knowledge. And in doing so, We try and capture a diversity of knowledge and use mathematical approaches that don't force people to come to one decision or one opinion, but combine all of these different pieces of information, sometimes weighting them depending on the level of expertise of the individual to come up with a better collective decision. And that's where we combine those techniques that capitalize on the expert knowledge with the data-driven techniques like machine learning. And at the same time, at the end of the day, we like to develop models where we can make some of that logic transparent to the construction practitioner so that he or she can also see if this intuitively reflects their years of experience. So that's why I spoke earlier about the fuzzy logic techniques that allow us to do that. And at the same time, combining them with the machine learning, with the optimization techniques that are also based on artificial intelligence methods, and then ultimately putting them into some of the more automated methods like simulation modeling. Thank you.
So this is a discussion we probably could carry on for hours, I think. But at this point, what I'd like to do is go to the audience for some questions. And I think I'm going to be disappointed if one of the questions I don't get is, does artificial intelligence eliminate the need for construction managers? So with that, let's turn to the audience for questions. Thank you for listening up to now.